video, we're going to take a look at the power reducing formulas. And I think I mentioned at the start of this section, we're looking at double angle formulas, power reducing, and half angle formulas. For the power reducing formulas and the half angle formulas, we will always start with the double angle formula for cosine. That's going to be true regardless of which trig function we're trying to find a power reducing or a half angle formula for. This is the important one. And let's review why. Okay. If I look at the double angle formula for cosine, the one that falls out directly from the sum formula is that cosine of 2 theta is cosine squared theta minus sine squared theta. That's just cosine cosine minus sine sine with theta plugged in for both angles. Okay. That gives me a relationship between 3 different trig functions: cosine of 2 theta, cosine of theta squared, and sine of theta, quantity squared. Okay, but because these two are squares of trig functions, we can use our Pythagorean identity. I can replace cosine squared with 1 minus sine squared. So if I do that, I get cosine 2 theta is 1 minus sine squared minus another sine squared is 1 minus 2 sine squared theta. Now I'm down to a relationship between just 2 trig functions. Okay, and you'll notice this is sine squared, but this is cosine just to the first power. It's evaluated at a different angle, but it's the first power. So this one's going to give me a way to go from sine squared to the second power to a cosine to the first. That's what I mean by a power reducing formula. Okay, and alternatively, I could have replaced the sine squared with 1 minus cosine squared. And if I do that, I get my third version. I'm purposely leaving a little bit of space right here because I'm going to manipulate this one in a moment. Cosine of 2 theta would be 2 cosine squared theta minus 1. Because, of course, if I replace sine squared with 1 minus cosine squared, I'm going to have to distribute that negative to the minus cosine squared, and it gives me a second positive copy of cosine squared. Okay. So all the power reducing formulas are going to do is take these 2 versions of the double angle formula for cosine, which give me a relationship between either sine or cosine squared and cosine to the first power evaluated at 2 theta, and I'm just going to solve it for the trig function squared. So if I do that, let's see. I think what I'm going to do actually, because I prefer to have my sine squared positive, I'm going to add over the sine squared and subtract over the cosine 2 theta. So this is going to give me that 2 sine squared theta is equal to 1 minus cosine of 2 theta. Okay, excellent. And then to solve for sine squared theta, I would simply divide by 2. So sine squared theta is equal to 1 minus cosine 2 theta all over 2. That's the power reducing formula for sine. It really is just rearranging this version of the double angle formula for cosine. Okay. This is something that gets used a lot in second semester calculus, and then again in third semester calculus for that matter. So you will see it a lot. It's a very quick derivation. Okay. So some of you might have it memorized, some of you might accidentally memorize it because you derive it so quickly, but it's really easy to forget because it's going to be very similar to the power reducing formula that we're going to get in just a moment for cosine, and it involves a subtraction problem. You got to remember when you've got a subtraction problem that order matters. So if you're like, oh wait, it's the subtraction one, is it 1 minus cosine or is it cosine minus 1? If you remember, great. If not, it's a very quick derivation. Okay. All right, here, this one's actually even nicer because the cosine squared is already positive. So I could solve this one for cosine squared. I'm just going to say 2 cosine squared theta is equal to cosine of 2 theta plus 1. And then, of course, to solve for cosine squared theta, I would divide by 2. So cosine squared theta is equal to cosine of 2 theta plus 1 all over 2. Excellent. And of course, these are the power reducing formulas for sine and for cosine, but I can now get one for tangent as well. Because tangent squared of theta would be sine squared of theta over cosine squared of theta. But I've got power reducing formulas for both sine and cosine. Sine squared is 1 minus cosine 2 theta over 2. Cosine squared is cosine 2 theta plus 1 over 2. I've got this fraction divided by this fraction. I would just flip and multiply. So I'm going to get 1 minus cosine 2 theta over 2 times 2 over cosine 2 theta plus 1. Those 2's cancel, and I get 1 minus cosine 2 theta over cosine 2 theta plus 1. And of course, it doesn't matter whether I write that as cosine 2 theta plus 1 or 1 plus cosine 2 theta, but on top, the order of the subtraction matters. Okay. So that's my tangent squared theta. That's also a power reducing formula because I'm writing the second power of tangent in terms of just a first power of cosine. This one's a little bit more complicated because it's a fraction of a first power of cosine and another first power of cosine, but it does still reduce the power. Okay. So very neat trick because although we're not quite ready to do second semester calculus stuff, I think you can imagine that sometimes it's easier to deal with a first power of something than to deal with something squared. And so this makes some of the calculus that we want to do a little bit easier because we can reduce the power that we have.